Check it out. We have the same graphs as before. We have the pansy line representing the motion of buggy 1 at 1 meter per second. Notice that it's steeper, the slope is steeper than the plot for buggy 2, which has a slope of 0.5 meters per second, half as fast. And this is in Hunter Green. So both start at the origin. So if this were a race, it really wouldn't be much of a race because the fast car is going to increase its lead from the get-go. So it's already ahead and it's just increasing the distance that separates the two cars. So it's really not very interesting as a race unless we try something like put the slow car at a position where it has a head start. So maybe if the track is finite, it's going to reach the end of that finish line before the fast car. It's possible. So let's see about that, okay? We can actually do that in Logger Pro. That's one of the cool facets about it. So what we can do is go into Insert a Graph. In order to do this, we start fresh here like that. We get rid of the old one, and we see our data, yay. So we have this graph. I'm going to make it bigger. Okay, it actually has the data for the first buggy, which is cool. We can keep that there as dots. And, we'll go to Graph Options, and we'll turn on the other one as well for buggy 2. So I'll hit position for buggy 2, okay, and those are the dots for buggy 2. Excellent. So the next thing we're going to do is go to Analyze, and we're going to go to, instead of linear fit or curve fit, go to Model. We can manipulate the model a bit so that it will go, so we can move the line actually up or down accordingly. Okay, so here we go. We want the linear model here. We want the equation of a line, the slope times t, which is the horizontal axis, plus the y-intercept. Okay, in this case, we want the slope to be 1, that's good, and the y-intercept to be 0. We want it to start at the origin. This is the fast car, and there it is. And linear fit options would give me the ability to change the font size, make it bigger, and change it back to pansy, because we want it pretty again. Okay, so on this graph over here, we're also going to go to Analyze and Model. Now we're going to go with the second car, so buggy 2 like that, okay? And what we're going to do is change that slope to 0.5, and the y-intercept this time is that head start, and we were looking in the lab at 1.4 meters. So we hit OK, and there it is, okay? And we'll go to Linear Fit Options and Appearance, and we'll go to size 22, and we made that, so we'll have the same color as last time, Hunter Green, hit OK. The cool thing now is check this out. I'm going to do it for this line, enable line drag. And that's going to enable me to move it up or down accordingly, which is pretty neat. You'll see why in a moment. Okay, so we look at this right now, and this has a scale of 0 to 2.5 seconds over here. And the thing is that we don't see what's going to happen. We need to zoom out a little bit. So there's a feature to do that. The auto scale is not going to help. The data is already scaled appropriately, but we want to go beyond the data and extrapolate, which means look beyond the data and predict what happens. So I'm going to zoom out, hit that button over here with the negative magnifying glass. What I'm going to do is region it so it looks a little bit better, and we can see from time equals 0 to time whatever there, hit plus to zoom in, and what we can see is that there's an intersection. That intersection represents the moment when the fast car will overtake the slow car. They meet, and what we can see is that if our track was 3 meters, I think that's what we had looked at before, the purple line here, the pansy line, reaches it first. Okay, and so the green line reaches it sometime later, which means that because this point over here is before the finish line, the point where they intersect, the fast car is going to win this race still. So what we'll actually look at in a bit is, hey, where could we put the head start so that the race ends up in a tie? But let's investigate this a little bit further. I want to show you some more cool features of Logger Pro. So I can actually zoom in pretty easily with a click drag. Okay, I'll hit the plus sign after that, and so we get a closer look over here. So we're getting to see like where the intersection is. It looks like about 2.8 seconds and 2.8 meters. So because the slope is 1, that kind of makes sense. Now, if we want to get this in real detail, and what you're going to end up doing is go to Analyze, and there's this thing called Interpolate. Okay, so this little window comes up here. Font, again, is too small. Let's make it big. Hurrah. Back to 22, I think is fine, okay? Now it's got all these numbers here, and I swear I hit 22, didn't I? Yeah, I maybe didn't hit OK. Okay, yes. There, it's big. Okay, so now you can see that there's this vertical line, and it's kind of explaining what the values are, all right, for time and position. And so what we see is that it's just tracing one of the lines, and I want to find that point of intersection. So it's right here. So the time is about 2.8 seconds, so is the position. So this gives us a way to actually look at that intersection. What I don't like about it is all the crazy numbers at the decimal point. This is nuts. We don't want it. We just want the, like, 3 is perfect. So 2.80. 2.80 is totally fine. We don't need all those crazy digits. They don't tell us much of anything. They're not significant. We only want 3 as a rule of thumb. So we'll leave it like that. So the other question was, well, how can we find out? Here's, let me zoom out again, and we'll go to spot 3 meters here. Here's the end of the track. Well, at what head start would we need to place the slow car so that it works? Well, you can see the cursor is kind of doing some crazy things. I'm going to make it a little cleaner by going to Analyze and turn off Examine there, which is the interpolate, okay, right? So it's a little cleaner, and what we see is that if I go to this dot over here, I clicked on the ability to move the line up or down. So see how it's got the arrow up or down, and now it's just the crosshairs back to arrow up and down. Well, if I click drag, look at it. I can move and see the y-intercept over here is actually changing its value. All right, so I can change its head start. So what I'm going to do is just kind of lay it close by like that, so that it has some type of intersection at 3, which is the end of the track. I'm going to zoom in and make sure it's as close as we can do it, like that. All right, and looks like right about there is fine. I'm going up and down like so. Okay, so about 1.5 meters, it says, is the position I need to place the slow car for it to meet the fast car, which makes a lot of sense because it goes half as fast, so it should be put halfway down the track. Okay, so we're able to solve this with a situation where we have the intercept representing that position. Okay, now let's go back. I'm going to do one more thing, and that is we want to look at a situation where we can model this such that it's moving backwards, right? And in moving backwards, where would they intersect if it were placed somewhere along a track? Okay, like at the 4 meter mark. Okay, so I can change that, and here's what I'm going to do. I'm going to keep the slope the same, but make it negative. Boom. Okay, and the y-intercept I'm going to put it about 4 meters, I think, for the activity that we did before, like that. Notice that the slope has changed, and we have an intersection point over here. Okay, so very quickly we can also predict where these two cars, if they were moving at each other, this is the smash 'em up derby scenario, would meet and pass each other or smash into each other. Okay, if it were a perfect line. So here it is. That's the point right there. All right, and it's not really in between anything that I can recognize very easily. So I'm going to go back to that Examine tool or with Interpolate. And of course it didn't remember that I wanted the font larger, so I can do that again. Poof, 22, font size, and there it goes with all the crazy digits. Okay, so here is where the intersection is. About 2 2/3 seconds, 2.66 seconds at position 2.26. So that's where they would meet if they were to find a head-on collision. So we can totally do this for the lab. And what I'd like you to do for that lab, of course, is to use this modeling tool to predict where they're going to meet and then test it out and get video to compare the actual event from your predicted one. All right, we did it. And so you got to see some of the cool features of Logger Pro, stuff that, again, some of the other graphing programs probably not able to do. Not easy to do this by hand, although you could. So we love this thing, and I would, because it's a free software program, I hope you consider loading it on your system also. With that, it's Morad.